Hello everyone, in this video I'm going to show how to detect serial correlation or correlated observations using sushi restaurants data. And then I'm going to show how to get robust standard errors if you have the serial correlation problem. On the screen you see a data from a sushi restaurant, and the data is a monthly sales data from 2018 to 2019. And we have also advertising cost and unemployment as predictor variables. First, we set our directory on R, and next we upload the data in a data frame and call it my data. And then you need to install package sandwich. So you need to use this command, getting rid of the hashtag sign. Since I have already downloaded, I didn't make this command active. And next, to activate this, you need to use library function. The next step is we are going to regress sales on advertising cost and unemployment. So we call it that regression regressor. And as you see here, sales is a response variable and advertising cost and unemployment are predictors. And then finally, we get residuals from this regressor and save it in an object called multiple_receipt. Next, we are going to use seg function to create a time variable and label that as t. This t has the same number of observations as the residuals that we get from multiple regression. Then we use the plot function. We also use the abline function to insert a line at the x-axis. So let's start. T is equal to seq, open the parentheses, from is equal to 1 to 2 is equal to length multiple receipt, and then control enter. So we have a variable called t here under values. Next we plot. We want to plot residuals from the multiple regression and then t. xlab, this is the title for x-axis, is time, and then ylab is equal to residuals, and then control enter. And then we are going to type abline h is equal to 0, and then control enter. Now you can see the scatter plot under plots pane. In order to detect serial correlation, we plot the residuals sequentially against time. And when you look at this picture, you see a wave-like movement in the residuals over time, first clustering below the horizontal axis, then above the horizontal axis, and again below this horizontal axis, and so on. This behavior represents a serial correlation in the residuals. So when you have a serial correlation, standard errors are not reliable. Therefore, next we learn how to get robust standard errors. We use the Navy-West function in the sandwich package to calculate robust standard errors for the OLS estimators. By using the option white is equal to false, we are asking for the most basic correlation. So let's type it, Navy-West, and then in the parentheses regressor, comma, white is equal to false, and then control enter. R returns here a table. This output represents the variance covariance matrix, where the diagonal elements contain the variances and the off-diagonal elements contain the covariance of OLS estimator. Because we are interested in the standard errors, we simply take the square roots of the diagonal values of the matrix. In order to find the standard errors, we can label them as multiple standard errors. So let's write it multiple SE is equal to, you are going to get the diagonal of this Navy-West, or we can just copy paste this command in the diag function, but we don't need to include this. Let's get rid of this one. And then here, since we want the square root, we are going to get square root of this whole thing. Yes, and control enter. And let's type multiple .se and then control enter. Now we can see the standard errors for intercept, advertising cost, and unemployment on the console pane. So this is how you get corrected standard errors if you have the problem of serial correlation using R. Thank you for watching the video.